So we're going to have a look at finding the square root of 3 plus 4i. I've plotted that on the complex plane, the point 3, 4, as represented by a point. We can see that its distance from the origin would be just by Pythagoras' theorem with 3 and 4, it would be 5. So the modulus of that complex number that we're trying to find the square root of, the modulus of that is 5. Now, geometrically, what we do is we square root the modulus. So root 5. And then that was theta there. That was the argument of 3 plus 4i is theta, whatever that is. And we want to halve the argument. So we want cos theta on 2 plus I sine theta on 2. And then we'll take into account the fact that we have another answer at 180 degrees to it, and so on. Now, I know roughly where this answer will be, shrunk down and in here somewhere, because that's about half of theta on 2, and of course the other answer will be there. So I know where the basic answers have got to be, but how do I find this theta on 2? Because it's not a simple halving pi on 2 or something like that like we've done before. Recall we've looked at this formula, cos squared theta on 2 is cos theta plus 1 on 2. So I'm going to use that, and I can look at this to find cos theta. I can read it off as 3 over 5. So cos squared of theta on 2 is equal to 3 over 5 for cos theta plus 1 all over 2. Right, now, if I do a bit of calculations on there, that's actually 8 over 5 over 2. So it's 8 over 10 if I simplify that fraction. And because I'm squaring it and I just want cos of theta on 2, then I want plus or minus the square root of 8 over 10, or plus or minus the square root of 4/5. So I jump straight to there. Now we know, because cos squared plus sine squared equals 1, we can easily find sine theta on 2 as well from this. Sine theta on 2 will just be the square root of 1 minus 4 on 5. Because cos squared plus sine squared equals 1. So the square root of 1 minus 4 on 5 is the square root of 1/5. So I can find that out fairly easily. And what I might do is I might write these in simplified form. So this one here is plus or minus 2 root 5 on 5. And this one here is plus or minus root 5 on 5. So I find actual values of cos theta on 2 and sine theta on 2 without actually finding the size of the angle. And now I can replace that in here if I need to. Root 5. Now cos theta on 2, we'll start with the positive. It's 2 root 5 on 5. Plus I. Sine theta on 2 is root 5 on 5. So root 5, this is root 5 times 2 root 5 on 5, which is just 2. And the root 5 times root 5 is 5 on 5, which cancels. So it's just plus I. So that's one of my square roots geometrically. And that's the one I pointed out would be about here. Square root of 5 and half the angle. And it makes sense that both the real part and the imaginary part are positive. The other one will be around here at 180 degrees. So they'll be the ones where they're both negative, which is revealing itself here, but I don't need to worry about that. I'm just going to be able to use this geometrical approach to write down that the square roots are, so I'll just write answer here, 2 plus I and minus 2 minus I here somewhere around that 180 degrees from the original. So that's a way to find it if you're going to work geometrically. I'd like to have a go at it algebraically as well. If I consider a number x plus iy that is the square root of 3 plus 4i, then if I square that number, it will equal to 3 plus 4i. So x squared minus y squared will be 3, and 2xy will be 4. We've been through this before. We're equating the real parts and the imaginary parts. If you expand that, that's what you'll get. We've also been now to the point where you can tell that x squared plus y squared is the mod of z. And the mod of z is equal to root of 3 squared plus 4 squared. So it's just equal to 5. And that's a little trick, but it's very helpful. Because if I add those two together, I get 2x squared equaling 8. So x squared equals 4. So x equals plus or minus 2. And if I subtract, maybe the blue one minus the black one, y squared minus y squared is 2y squared, equaling 5 equaling 2. Then y squared equals 1. So y equals plus or minus 1. And once again, I've got to figure out which, does the plus 2 go with the plus 1 or the minus 1 or whatever. And I can tell up here that these are timesing together to give a positive number, so they must both be the same sign. So either the x and the y are both positive or the x and the y are both negative. Also, from my geometrical representation, I can see that they're in this quadrant, so x and y are both positive, or 180 degrees around from it, they'll both be negative. So I can write out my solution here, that my answers are x is 2 and y is 1, so just 1i, or x is minus 2 and y is minus 1, so minus 1i. 2 plus I and minus 2 minus I.